Hello, this is Mr. Henry, and welcome to Lesson 1.4, Write Equations and Inequalities. The essential question says, how do I translate verbal sentences into equations and inequalities? In the last lesson, we talked about writing verbal expressions. Expressions are problems that don't have an equal sign. So it was like 3 times 5 or 5m or something like that. That's what we got in the last lesson. Today's lesson is all about equations and inequalities. So, we have two get the goofs here, and these are verbal expressions from the last lesson. The first one says 5 more than 3 times a number w. Well, let's see. 5 more than 3 times a number w. So technically, this is correct, and actually that is correct as well. They are both correct answers because if you remember, no, I guess we haven't talked about that yet. One of the properties we're going to learn about is the commutative property of addition, where you can switch addition problems back and forth and you still get the same answer. So like 3 plus, that was stupid. How like 3 plus 9 is the same thing as 9 plus 3. You're still going to get the same answer. Well, this is the same deal. 3w plus 5, or 5 plus 3w, gives you the same answer. The second one says the number of months in y years. So if you think of a number in your head, say like 5 years, how many months would be in 5 years? Would you take 5 divided by 12? No, that wouldn't work out. You need a bigger number. So you'd probably take 12 times y, because there's 12 months in each year. So if you do each year 1, 2, 3, 4, 5, 12, 12, 12, 12, 12, in 5 years there would be 60 months. Okay, our vocabulary, an equation. An equation is a math problem where the two sides are equal. And it also has that guy in it, where the two sides are equal. An inequality is a math problem where the two sides are not equal. Sorry about that. The two sides are not equal. One side is bigger than the other, one side is smaller than the other. It might be greater than or equal to, less than or equal to. It could be all kinds of things. Both problems, though, when we get to solving them later on throughout the school year, Chapter 3 for equations, Chapter 6 for inequalities, when we start getting to them, you're going to see that they're solved pretty much the same. Now here, also in the vocabulary box, we have a place for our symbols, the meanings, and some of the words that kind of mean that. So let's go ahead and first put down our symbols. So we have like the equal sign. We have a less than, a greater than, a less than or equal to, and a greater than or equal to. So these 5 different symbols are the symbols we'll be using today. Now, obviously this one means equal to. And a couple of words you'll see that are associated with that. The word is, or the same as. And the is would be like, if it says like 3 plus 5 is 9, or 3 plus 5 is 8. That is our equal sign. This is a less than, and we can use the phrase fewer than. You could also use less than. So if it says John has fewer than 5 apples, then you'd use a less than symbol for the number of apples he has. He has fewer than 5. He has less than 5. This one is called greater than. And you use more than. By the way, these words, this is not an exhaustive list. This is not every single thing that means that. These are just kind of the most common ones you'll see frequently. The next symbol is a less than or equal to. less than or equal to. So it has the less than symbol in it, but it also has this other little line that's kind of like this equal to sign. So it's almost like you take the equal sign and a less than sign and you stack them on top of each other. That's really what it means. It's a less than, but also could be equal to. And one of the key phrases for that is at most. If I said, I am at most 29 years old, that means I can't be more than that, so I'm either 29 or less than. And the last one is greater than or equal to. And you probably guess if this was at most, this would be at least. So those are some to help you out as we're going through our different lesson problems here. Make sure you understand which symbols go with which words, mean which things. So let's get to it. First problem here is we want to write these equations and inequalities. So we're just writing them. We're not solving them. We're not getting the answer. We're just writing. So our first problem says the sum of 5 and a number is 19. Well, there's that sum again. That means add. So we're adding 5 and a number. So 5 plus a number is 19. So the sum of the adding of 5 and a number, which we don't know what that number is, which is why we put a variable, is 19. Simple enough. Letter B. A number is more than, so a number is more than the quotient of 3 and the number. So a number is more than, the quotient means dividing. So we're dividing 3 and the number. A number is more than the quotient of 3 and the number. So you're just taking the words, turning it into equations and inequalities. Go ahead, pause the video, do these next two on your own, letters C and D. Hit play, and then we'll get back together and do it again in just a second. Alright, letter C says the product of 8 and a number is at least 20. So the product is a multiplication. So if I'm multiplying 8 and a number, looks like that, this is at least 20. Now, at least. If something is at least 20, it means it's either 20 or bigger. So I'm saying this is greater than or equal to, because imagine you're like a little kid who wants to get on the roller coaster and you have to be at least this tall to ride. Well, if you're that tall, you can't ride. You have to be that tall or taller. Now you can ride the roller coaster. So at least means that much or a bigger. Have to be at least that tall to ride, that or bigger. Letter D. The difference of 3 and double a number is 12. So the difference, we're subtracting. So we're subtracting 3 and double a number. Okay, so we're subtracting 3 and double a number. Well, if you're doubling something, it's 2 times that number, and that is 12. So 3 minus 2n equals 12. The difference of 3 and double a number is 12. That's example 1. Taking simple word problems and changing them into math problems. And by simple, I mean they're not, there are no stories involved here. It's just basically giving you an expression, a sentence that translates almost word for word into an equation or inequality. The second example here is we want to check to see if a given solution is actually correct. So for example, in letter A here, it says, is 5 a solution to this equation? We want to know, is 5 the answer to that? Well, the way we can do that is you take the given possible solution. We don't know if this is the answer yet. You take that and you plug it in for the variable. So here, I'm going to take 8 minus 2 times 5. And you want to know, is this true? And by what I mean by is this true, I mean if you do all the math on this side, you work through your steps, blah, 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 do you get equals 2 on the other side? So let's see. If we do our order of operations, we'd multiply first and get 10. Write down the rest of the problem. 8 minus 10. 8 minus 10, for those who don't remember, is actually a negative 2 because you can't, if you have 8 of something and you take 10 away, you are now less than 0. Well, is negative 2 equal to 2? No, it's not equal to 2. That means 5 is not a solution to that problem. This is not true, which means 5 is not an answer. That's what we mean by is it true. Letter B. Do I have space over here? Nice. All right, I'm going to do letter B over here. You have more space in your paper than I do on the board. Letter B says 5 plus 3n is less than or equal to 20, and then we have the semicolon 3. This semicolon 3, that's the possible solution. So we're going to take that and plug it in for our variable. I don't care. And now we want to check to see if this is correct. So order of operations says that we do the multiply first. So that's a 9 plus 5. And then 9 plus 5 is 14. Is this true? Is 14 less than or equal to 20? The answer is yes. 14 is less than 20, which means 3 is a solution to that problem. So that is how you do equations. That's how you check an equation or an inequality. You plug the number you get in for the variable and see, do you get a true statement after you've done all the math? Okay? So I've done A and B. It's time for you to do C and D. There's C, there's D. Go ahead, pause the video, do those two on your own. When you're ready to continue, hit play, and we'll go through it together. Alrighty, let's see what we got here. Letter C. We're going to take 5 and we're going to plug that in for D. So this becomes a 5 times 3 equals 9 minus 24. Okay. And now we just do the math. So that's a 15. And yes, I am following order of operations. I'm doing the multiply before the subtract. Now we got to subtract over here. That gives me 9. So I've got 9 equals 9. Is that a true statement? Does 9 equal 9? Yes. So 5 is a solution. Letter D. We want to know, is 3 a solution to that? So we plug in 3 for the x. And then we would multiply and get 6. 6 minus 7 is a negative 1 because you'd have less than 0. You have 6 of something. You take 7 away, you're less than 0. Is negative 1 less than or equal to 3? Yes. So that is a solution. 3 is a solution to this because we plugged it in and we got a true statement. Alright, so that's what it takes to check to see if a number is a solution. You plug that number in for the variable, you do the math, and you check to see, do you get a true math problem? Next is very, very easy. These are called using mental math to solve, which means you are doing this in your head without a calculator. So the first problem here says 8 plus g equals 19, and we want to know, what is this g? We're trying to find out what that thing is. So just think in your head. If you have 8, what would you add to get to 19? Hopefully you think that if you would add 11, you'd get 19 because 8 plus 11 is 19. So we'd say G equals 11. Letter B. This one's a little bit trickier. It says A divided by 5 equals 9. So you got to think about what number would you divide by 5 to get 9. Now, some people get all wrapped up and they think, oh, you have to do like 9 divided by 5, which doesn't work out, by the way. So really what you could do is you could start counting by 5s until you find something. So you can go 5. So 5 divided by 5 would be 1. 10 divided by 5 would be 2. 15 would be 3. 20 would be 4. 5. 6. 7. 7. 8. 9. If you take 45 divided by 5, you'd get 9 for an answer. That means A is 45. This is mental math. Now, we're going to see when we get to Chapter 3 a much easier way of solving these problems. And it's a very structured way of solving the problems. But for now, we're just kind of easing ourselves into it using some mental math. Here are 2 problems for you to try. Some nice easy mental math, C and D. Go ahead, pause the video, do these 2 on your own. When you're ready to continue, hit play, and we'll go through it together. Alright, so letter C, you should have found that R equals 3, because 9 times 3 is 27. And letter D, P should equal 9, because 9 minus 6 is 3. If you said 3 minus 6 is less than 0, it does not equal 3. 3 is not correct. The correct answer is 9. Couple problems for you to do out of the textbook. These come from page 22, numbers 2 through 7. Go ahead, pause the video, do these problems on your own right now, and then hit play. We'll get back together in just a minute. All right, number 2. I'm going to do the problems down here. So it wants us to find if the given number is a solution to the problem. So 9 minus 5, does that equal 4? I plugged in 5 for the variable. And the answer is yeah, because 9 minus 5 is 4. So yes, that is a solution there. Number 3. Plugging in 7 for B. So 7 plus 5, is that less than 15? 7 plus 5 is 12. Is 12 less than 15? Yes. So that is a solution. Number 4. 2, we're plugging in the 9 for n. So 2 times 9 plus 3, is that bigger than or equal to 21? Well, 2 times 3 is 18 plus 3. 18 plus 3 is 21. Is 21 greater than or equal to 21? Well, it's definitely not greater than, but it is equal to, so which means this is a yes, because you're allowed equal to's in this as well. So that is a yes. So all 3 of those were solutions. Hopefully you said yes for all 3. Okay, I'm going to erase these to do, no, I don't even need to. These problems are easy. These are mental math. Number 5, change color. M equals 5, because 5 plus 6 is 11. X equals 8, because 5 times 8 is 40. And this is the hardest of them, but R equals 40, because 40 divided by 4 is 10. And there we are. Those problems are done. The last thing we have here are 2 wordy problems. Couple more out of the textbook, and then we're done. Example 4 says, Tyler would like to make no less than $610 selling coffee mugs online. If he sells 28 mugs for $22 each, will he achieve his goal? First thing first, verbal model. The verbal model helps organize your thoughts, get them down on paper to make sure you're thinking about the problem correctly. So, he wants to, so money made, the money he wants to make here, he wants it to be no less than $610. So he wants this amount of money he made to be bigger than or equal to $610, right? No less than, which means he's that much or bigger. So he wants the money he made to be bigger than or equal to $610. Now, as far as how much money did he make? Well, he sold 28 mugs for $22 each. That's multiplication. If it's $22 28 times, so $22 times 28, we want that to be bigger than or equal to 610. And let's see. 22 times 28. Calculator. 22 times 28 equals 616. So we got 616 is bigger than or equal to 610. Is this a true statement? The answer is yes. He made $616, which is bigger than the 610, so he met his goal. Will he achieve his goal? Yes, he will. Letter B. Letter B, I'd like you to try on your own. It says, during a boat race in 2002, the U.S. team finished 6 hours after the New Zealand team. The U.S. team finished in about 173 hours. What was the winning team's time? Pause the video, do that on your own, and when you're ready to continue, hit play, and we'll go through it together. Okay, so let's see here. So we're doing like a boat race, right? So the U.S. team finished 6 hours after New Zealand. So if you take the New Zealand time minus 6 hours, you get the U.S. time. Or wait. No, you'd plus 6 hours, wouldn't you? Here's another way of doing this. How about this? U.S. time minus 6 hours equals New Zealand, right? Because imagine the U.S. time finished in like 106 hours. They finished 6 hours after them, which means they finished in 100 hours. So my little verbal model works out here. This is not the actual times. Now, verbal model. Now we plug in our information. We know the U.S. team finished in 173 hours. So 173 hours minus 6, that's 167 hours was the New Zealand time. Now, double check your answer, make sure it makes sense. Is this 173 hours 6 hours after the 167? Well, yeah, if they're doing a race, the first team finished in 167 hours. 6 hours later would be 173 hours. So yes, this answer makes sense. That is the correct answer. All right. Please do number 9 out of the textbook, and I have it up here. So it says in example 5, which this is example 5. Suppose that, so how about this? Suppose that the players play 16 games. Would an average of 22 points per game be enough to beat last year's total? So that's kind of out of context. We don't know what they're talking about. So it says in a basketball, player scored 351 points last year. If the team plays 18 games this year, will the average be 20 points per game enough to beat last year's total? Okay, so this is the stuff that we don't really care about. We care about this. A basketball player scored 351 points last year. Now it's saying, suppose the player plays 16 games. Would an average of 22 points per game be enough to beat that total? Pause the video, do it on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so here's what I got. So I want to find out, is the total, which is this 351, is this, we want to find, is this other score bigger than the last one? So we want to know is, I'm trying to get myself organized here, is the 16 games times 22 points per game, is that bigger than the 351? We want to know, is that enough to beat last year's total? So we want this thing to be bigger than last year's total. Well, last year's total was 351. Is this 16 times 22, that's 16 points a game for 22 games, is that bigger than 351? Well, I don't know. Clear, 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 clear. 16 times 22 equals 352. So is 352 bigger than 351? Yes. So is this total going to be bigger than last year's total? Yes, it will. Okay. So this summary question says, how do you write equations and inequalities? Again, see if you can put down an answer, a sentence or two, a little explanation on how you write down these equations and inequalities. Pause the video, do it on your own. When you're ready to continue, hit play. We'll go through it together. I have here, first you identify any keywords for clues on add, subtract, multiply, or divide. Then you set up your equation. Also, if you're talking about a word problem, you would first start with a verbal model, then change your verbal model into your equation. Alright, and the homework comes from page 24, numbers 2 through 24 evens, and number 39. Okay, and you'll find number 39 is actually on the next page, page 25. This has been lesson 1.4. Thank you for watching.